Cooking Up Calculus! Today we're going to be taking a look at how derivatives affect the shape of a graph.
While also cooking up some delicious cookies.
So let's get all our ingredients laid out and we can get started. Okay, so here we've got 2 1/4 cup of flour, we've got 3/4 cup of brown sugar, we've got 3/4 cup of white sugar, we've got 2 sticks of butter, 2 eggs, some vanilla bean pods, we've got a teaspoon of baking soda, a teaspoon of salt, and for our toppings, we've got chocolate chips, we've got butterscotch chips, and we've got cinnamon.
You must preheat your oven to a temperature of 350 degrees.
So now that we have our base dough finished, we're going to be adding some different mix-ins.
This is to represent our original graph, our first derivative, and our second derivative.
So for our original graph, we've got some chocolate chips. For our first derivative, we've got some butterscotch chips. And for our second derivative, we've got some cinnamon. Mix-ins added, it's time for the calculus.
So the subject of today's episode is how derivatives affect the shape of the graph. We'll be discussing how to find max and mins, concavity, inflection points, and we'll be discussing how to tell whether or not the graph is increasing or decreasing.
Okay, so the first step is to decide what our primary graph is going to be. For us, f of x is equal to x to the 4th plus 3x cubed minus 2. And we're going to be using our chocolate chip cookie dough to represent that graph.
We'll save you the trouble of graphing it and just show you a rough approximation of what this will look like.
Now we want to figure out where our graph is increasing and decreasing, and the best way to do that is using the first derivative test.
To show the first derivative, we're going to be using our butterscotch chip cookie dough to shape the graph. It's actually pretty easy to tell when your graph is increasing or decreasing when you use your first derivative. We can tell that a graph is increasing when your first derivative is above 0. Likewise, when it's below 0, your graph is going to be decreasing. Here, because our f of x is decreasing from here to here, our f prime is negative from that point as well. After that, our f prime of x is continually positive, showing that from here on out, our f of x is increasing.
Using this first derivative, which equation is 4x cubed plus 9x squared, we can also look at what the maximums and minimums of our original function are.
Considering maximums and minimums, it's important to remember that when your first derivative changes from negative to positive, it indicates a minimum. Likewise, when it changes from positive to negative, it's a maximum. Now, using these graphs, there's only one time that we actually see a minimum or maximum happen, and it occurs right here, when our first derivative changes from negative to positive, indicating on our original function a minimum.
That was an amazing explanation, Lauren. You really helped me figure out how to use the first derivative better myself.
I'm glad it was helpful. Now it's time to take a look at our second derivative.
To do that, we're going to be using our cinnamon dough to form the second derivative equation, 12x squared plus 18x.
To use our second derivative for is looking at concavity. When our second derivative is positive, then our original graph is concave up. In turn, when it's negative, our original graph is concave down. Now, when looking at these graphs, we can see that our original graph is concave up from about here to here because our second derivative is positive during these intervals. Now, it's concave down from about here to here because this is where our second derivative shifts to a negative. Now, after this point, our second derivative is positive again, and so it means that our original graph is once again concave up. While on the topic of concavity, let's also take a second to look at inflection points. Inflection points occur when your second derivative is 0. Now, on this graph, this happens 2 times. One when our second derivative changes from a positive to a negative, and once more when it changes from a negative to a positive. On our original graph, this means that our concavity is changing, which means that it goes from concave up to concave down, occurring right here, and then also from concave down to concave up, which occurs at this point.
Whoa, Lauren, that was so much information.
It really was, but I hope we've helped you better understand how derivatives affect the shape of the graph. Now, Hannah, should we bake and eat these cookies?
I thought you'd never ask. That's my favorite part.
Place in the preheated oven and bake for approximately 10 minutes. After 10 minutes, remove from oven, let cool, and enjoy.
Cheers.
Delish.
A delicious graph.
Calvin! Good boy.
Yeah, roll that dough. My hand's just sitting idly over here. The big boy.
The big boy.
The biggest boy.
I don't have.
Our best director.